Roland Ratzenberger's tragic death on April 30th, 1994, at the San Marino Grand Prix in Imola remains one of Formula One's darkest moments. His accident, which occurred during a qualifying session, profoundly impacted the sport, spurring essential changes in safety protocols and car design to prevent similar tragedies in the future. How the accident happened. Ratzenberger, a 33-year-old Austrian, was relatively new to Formula One, but had a solid racing background. During qualifying, he was driving his Simtek S941 car when a minor incident in a previous lap led to severe consequences. On an earlier lap, his car struck a curb, causing slight damage to the front wing. This damage, seemingly minor, led to a catastrophic failure moments later. As Ratzenberger approached the high-speed Villeneuve corner, the weakened front wing broke off completely. This sudden failure disrupted the car's aerodynamics, reducing front-end downforce and control. As a result, his car lost stability at around 306 kilometers per hour, 190 miles per hour, and crashed into a concrete barrier head-on with devastating force. Medical findings and cause of death. The impact was severe. Ratzenberger's crash was a high-velocity, frontal collision, generating massive deceleration forces upon impact. Medical reports from the autopsy indicated that Ratzenberger sustained a basal skull fracture, a severe injury at the base of the skull often associated with high-impact, high-speed collisions. This fracture was fatal, and he likely passed away instantly or within moments of the impact. Contributing factors and investigation insights. Several factors contributed to this tragedy, both mechanical and procedural. Formula One's investigations, alongside Simtek's own inquiry, revealed some critical points that future drivers, teams, and safety officials should consider. 1. Structural integrity and wing design. Ratzenberger's front wing had suffered minor undetected damage in an earlier incident. While seemingly minor, this damage weakened the wing structure, which couldn't withstand aerodynamic forces at high speed. Improved front wing testing and inspection protocols could have identified such vulnerabilities. 2. Pre-session inspections and monitoring. Mechanical checks between laps were less rigorous in 1994 than they are today. Since then, pit crews have adopted much more advanced inspection technologies and protocols, including digital imaging and stress testing, to detect minor damages that might impact the car's integrity. If the Simtek crew had identified and addressed the minor front wing damage before Ratzenberger continued on his next lap, the catastrophic failure might have been avoided. 3. Safety barriers and impact absorption. The concrete barriers at Imola were common at the time, but lacked the energy-absorbing properties of modern barriers, like the safer steel and foam energy reduction barriers introduced in recent years. These new barriers dissipate impact forces more effectively, protecting drivers by reducing deceleration forces that can cause severe injuries. 4th, helmet and neck safety improvements. After Ratzenberger's crash, Formula One took steps to enhance driver head and neck safety. These developments included the head and neck support HANS device, which became mandatory in 2003. The HANS device has since reduced basal skull fractures by limiting head movement during impact and redirecting crash forces across the helmet and shoulders. 5. Medical and track safety upgrades. The crash led to significant overhauls in trackside medical response protocols. Medical teams became more strategically stationed along tracks, allowing them to respond within seconds to high-impact crashes. Improved communication systems between race control, medical teams, and track marshals also emerged, ensuring swift coordination in emergencies. How this crash changed Formula One forever. The legacy of Ratzenberger's crash provided the racing world with profound insights. 1. Racing safety systems. Routine and meticulous inspections of every car component before sending drivers onto the track have since become standard in F1. Drivers today are supported by thorough technical checks to prevent incidents linked to component fatigue or minor, overlooked damages. 2. Driver safety gear. Drivers must ensure that all safety equipment, including the hands device and reinforced helmets, are correctly fitted and optimized for crash protection. 3. Pre-race and post-lap communication. Drivers today are encouraged to report any minor impact or irregularity to their teams. Even seemingly harmless incidents can lead to dangerous structural weaknesses, as Ratzenberger's experience tragically demonstrated. 4th, track safety awareness. New drivers are now trained to identify dangerous track areas and the safest way to approach them, even at high speeds, using simulator data and historical crash data for better situational awareness. Could the tragedy have been avoided? Ratzenberger's death could potentially have been avoided with today's stringent safety protocols. His fatal accident underscored the importance of thorough mechanical checks, the significance of early warning signs like minor wing damage, and the necessity of rapid response and safety innovations, both in car design and track safety. His tragic passing was a critical turning point that, paired with Ayrton Senna's fatal accident the following day, set Formula One on a determined course toward heightened safety standards. Today, every driver benefits from the hard lessons learned at Imola, making Ratzenberger's death not in vain, but a legacy that safeguards the lives of drivers racing in his footsteps.